what you need to do is every variable or a computation that you perform is like an operation or a node within a graph. So initially the graph will be what is known as the default graph. The moment you create a TensorFlow object or TF, this TF here you see, this is the TensorFlow object, and again in the code, when we go into the code, it will become much easier to understand. So when you create a TensorFlow object, there is like a default graph which doesn't have any operations, no nodes or anything like that. So it's like a clean slate. The moment you assign variables or constants or placeholders, each of them is, in TensorFlow terms, it is known as an operation. Again, you need to get familiar with these terms, and they are not very intuitive. This is not really an operation. You're just creating a constant or a variable, and this C is equal to A into B would traditionally or would intuitively be an operation. Here you're actually performing an operation. But in TensorFlow terms, each of these, everything is an operation. So if you're creating a constant, that is an operation. Another constant or variable, that's an operation. So you can actually run each of these, and they're also referred to as nodes. And when you're in your session, you will actually run each of these. You can potentially run each of these nodes. Okay, so a typical example would look like this. So you have two constants created. A is equal to tf.constant, its value is 5, b is equal to this, and then you say c is equal to a into b, and then you create a session. Now remember, all this, you're just creating a graph. At this point, no execution has happened. Correct? So only at this point, once you create a session and then you say session or ses.run, C is when actually this whole thing will get executed. All right, so that is a different way of programming compared to our traditional way of writing programs. So you need to get used to this new format. And when we look at the code as we move forward, and when we look in the Jupyter notebook, it'll become much easier probably to understand this rather than in the slides. So these are the slides showing the code. But what we can do is go straight into the lab and take a look at the various examples that are there, and starting from the very basic one, how you create variables. And so these are some of the slides that are showing. So this is about how to create variables, how to create constants, and the variables or constants can also be strings. So this is like our first hello world program, and we will talk about placeholders, how to define a placeholder and how to execute and populate the placeholder values into placeholder. We will see these examples in the lab. Actually, I will run the code, and we will also perform a small computation of adding and multiplying these variables, and we will, in the end, we will take up a use case implementation using TensorFlow. So let's first go and see those examples and then come back and I'll explain this use case, and then we will execute the use case in the lab. So let's go and check our lab. Okay, so I'm in the Jupyter Notebook environment, and this is one of the development environments we can use. This is regular Python. Anytime you do Python programming, we use Jupyter Notebook, or there are other ways of using other tools like PyCharm and so on. But for this particular tutorial, I'm comfortable using Jupyter Notebook, so I will show you in Jupyter Notebook. So this is the very basic example to demonstrate how to create variables and constants and placeholders, and what is the difference between them, how they behave, and so on. And as I mentioned, the assumption here is that you know at least some basic Python programming or some programming language, so at least you understand the code here. And first two pieces of code, you will not need machine learning background, but when we do the use case or the case study, there it is expected that you know at least some basic machine learning concepts. So in case you need to brush up the machine learning part, you may have to do that before you go to the third one. But here, just at least some idea of programming will be sufficient. So what are we doing here in this particular line or in this particular cell? We are importing TensorFlow. It is as I mentioned, it is a library. So we are importing TensorFlow and we are calling it TF. So this is just a name. You can give it any name, but it is very common, and everywhere wherever TensorFlow programming is done, it is always named as TF, but you can name anything actually. Okay, so this will import the TensorFlow into my session. Now this is the way to create a variable. So let's start by creating a variable, and this is the name of my variable. I'm starting by giving a name called 0, and I say 0 is equal to tf dot variable, and then I'm giving the value of the variable here. So this is the very basic way and the simplest way to create a variable. We will see a little later there are other formats as well, but the bare minimum way of creating a variable is this. So I'm creating a variable by the name 0, and as I mentioned, you need to pay attention to the capital V here. In case of variable, it is a capital V, uppercase. Constant and placeholders are lowercase. Now I'm creating a constant, and the constant I'm naming it as 1, and the way to create a constant is tf dot constant, and then you give the value of the constant. So the value of the variable here is 0 and the value of constant here is 1. And again, constant you can also have additional parameters like a name and so on. Probably you must have seen in other tutorials or in other places where the code is written, but the basic format construct to create a constant is this. This is sufficient to create a constant. So I created one variable and one constant. Now what else can we do? Again, here there is no real execution happening. We are just building a graph. We have not yet executed any TensorFlow code. We are building a graph, and I will show you how the graph looks as well. First let us understand the constants and variables and so on, and then I will show you how the graph is generated and so on. So what I want to do here is I want to add 0 and 1 and put it into a new variable called new value. So what I do here, TensorFlow offers these methods like add, assign, multiply, or you have matrix multiplication, matmul, and so on, right? So I will use one of those methods, which is tf.add, and then pass these two as parameters. So we can add a variable and a constant. There are no restrictions on that. So this is a variable and this is a constant. So if I do this, it will be okay. I did not execute this code, so it is giving an error. Now we are good. Okay. So what it has done is new value will be equal to tf.add 0, 1. So then we have one variable and one constant. Now let's say I want to change the value of the variable, because that is possible, right? So we want to change the value of the variable to something, some new value. So we have, in this case, new value has 1 because we added a 0 and a 1. So new value has 1. Now I want to assign this to this originally what we called as 0. So I will call that as update is equal to tf.assign. So assign is basically changing the value. So that's what we are going to do here. Now it has not complained. We'll just say fine, right? There are no issues. Now let us try this something similar with this 1 as well. So 0 is a variable, so we were able to change the value, and we will in a little while we will see what exactly those values are. But before doing that, now let's say I will uncomment this part and I want to do something similar for my constant, right? 1 is a constant. Now I want to, let's say, change the value of the constant and make that also something different. Okay, so if I execute this piece of code, it will give an error. Now again, the error message may not be very intuitive. This doesn't say that you cannot do this for a constant. It will just say tensor object has no attribute assigned. Now that sometimes may be confusing, especially when you're starting. But the meaning here is that 1 is a constant and you're trying to modify the constant, so it will not allow. That's the reason it is complaining. So let's put that back in the comment, and okay, so that is done. So only variables you can modify. Now what do you have to do? Let's skip this piece of code. I'll come back to this in a bit. But let's say we start by creating, you remember I told you we need to create a session. So the way to create a session, there are a couple of ways of creating a session, but this is for beginners, this is the easiest way. All you need to do is assign a variable called ses, or you can give any name, and that is equal to tf.session. That is the session method here, and you create a session object by the name ses. Now what I'll do is I'll skip this as well. There is a purpose behind that. Now let's go ahead and run this piece of particular operation. You remember I mentioned that everything you need to run. So as of now the code has not really got executed. TensorFlow code has not got executed. You only created the graph. So only when you run through the session is when actually the program gets executed. So when you do this, now you see, observe that it is giving an error. Okay, the reason behind that is, remember we skipped these two lines of code for variables. Okay, this and then this. Now, this is something very, very important to observe. If you have variables in your code, what I mean by that is, let's say you are not using variables, but you have only constants and placeholders, then this will not complain and you will not get this error. But in our case, we also have variables. So whenever you have variables, in that case, you need to do an initialization. And this is just a standard code. There is nothing that we need to add or modify or anything like that. This is a standard piece of code. You create this name, of course, can be anything. You can give us any name, but this global variables initializer is what you need to call tf.global variables initializer. This will kind of initialize all the variables that you may be using. And then again, remember, this doesn't execute anything, right? So all you're doing here is you're creating an operation. But in order to run that operation, you need to also run this known as run init underscore op. So this operation you need to run after creating the session. All right. So we executed this. Now let us execute this. And now when I run this piece of code, it will run successfully. Okay. I hope you observed that. So it is whenever you use variables, these two lines of code. One is the operation. You need to create an operation for saying global variables initializer, and then you need to run, before running anything else, you need to do a session.run this operation. Okay. Again, only if you're using variables. Of course, you invariably in all your programs you will use variables. You cannot just write a program with constants and placeholders. So you can pretty much assume that this has to be there in pretty much all the programs. Now again, why this has not been taken care of in the library, that's a different question, but you need to keep in mind. And always remember, if you don't do this for whatever reason, if you've forgotten, you will get an error and the error won't be intuitive. So you need to remember this, that this could be because of the variables. Okay, good. So we have seen how to create a constant, and we have seen how to create a variable, and we have seen that you cannot modify or update a constant, and we have also seen if you have variables that you need to execute or have these two lines of code to initialize the variables. And then we have seen that after creating a graph, how to run the graph in a session. And I will show you a little bit more in detail how exactly the graph gets created and how it gets executed. But this was the first very quick code on creating variables and constants. Now we will keep going, and we will also show you, or I will show you the placeholders. But before that, one more small piece of code. So this is how you write a for loop. Okay, so we are saying 5 times you run this piece of code. Now, like any Python program, this is nothing different. So you have a for loop, and this is indented, that's the reason. And therefore you say session.run update. So this will run 5 times and it will get printed. That's all. So update will run for 5 times. Each time it will come and do this particular operation. That's all we are asking the system to do. So let me just run that and show you. So it will, okay. So it has done 5 times. That's for, it is basically adding, if you recall, it starts from 0, it adds 1 to 0, then 1 to 1, 1 to 2, and so on. So it's nothing but it is generating 5 numbers, 1, 2, 3, 4, 5. That's it. Okay. So then you can also have your constants as strings, for example. So you can also work in a similar way. You can work with strings. So most of the computation happens mainly on numerical values. So we normally handle numbers, but there will be situations where you may have to handle strings as well, or text as well. So this is an example of text operation. So you can, similar to numbers, you just create strings or store in constants. Instead of a number, you say hello is equal to tf.constant, and then you assign the string that you want it to be assigned. And then the next one is one more string, which is for world, and then you say add these two. So it is nothing but concatenation of these two words, hello and world. So we will do that. And remember, this is only creation of the graph, right? So in order to actually execute this graph, you need to run the session. Now you need to keep in mind, we don't have to create the session once again, because once you create a session, till you close the session, it remains valid. Okay. So we have created this session here. Now till you say ses.close, it will remain for you. So that's why we did not create one more. So we are just reusing that session, ses.run hello world. So in this hello world, what is the operation that we are doing here? The operation is add these two, concatenate these two. So if I run this, it will print hello world. Okay. Now that's string operation. Now we will take a look at placeholders. So this is slightly more complicated and something new even for people who have been writing programs. So, but I'll just explain it with a quick example. First of all, how do you declare or create a placeholder? You just do tf.placeholder, and the p is lowercase. Only in case of variables, the v is uppercase, but otherwise constant and placeholders, it is lowercase. And you just say, because as I mentioned, this is a placeholder that doesn't have any value. So you, unlike a constant or your variable, you will not specify any value. You just say what type of placeholder you want. And very often, most of the cases, it is a floating point. So we just say placeholder of type float32. So this tf.float32 tells the system that it is a floating point. Okay, and then so let me just run this, and then you can do some or define some computation, like for example b is equal to a into 2. Now remember here right now a has no value, but what we are saying here is at any point later on when a gets some value, then b should be equal to twice the value of a. That's all we are saying here. Okay, and also as I mentioned earlier, we are not yet executing anything. We are just creating the graph here. Okay, so now you have that. Now how do you feed the value or populate the placeholder? There is a certain syntax in which you can populate the placeholder, and you do that using what is known as a dictionary. You're all probably familiar, those with Python especially must be familiar with the dictionaries. So you need to create a dictionary and then pass that in order to feed the placeholder. So in this particular example, if I want to run something, if I want to calculate or compute b, obviously I need to feed the value of a. So the value of a I'm feeding using this dictionary, and I'm saying that a is equal to 3. Now there are multiple ways of populating the value of a, because typically this won't be just a scalar value like in this case, right? Remember scalar? So it's just one value, one number. Typically it would be a vector or a tensor. Very often it is a tensor. So we will see step by step. So we can start with the very basic example where a can be a scalar. So in this case a is equal to 3. That's what we are saying. Feed underscore dict. In this case feed underscore dict is the name of a variable, by the way. So you can't give anything else here. So if you just say feed is equal to this, it will give you an error. Alright, so keep that in mind. Either you specify feed underscore dict is equal to and give the dictionary, pass the dictionary, or you straight away, like in this case, this is another format. So let's see. First, let me execute this. It has given 6. Okay, I think let me see if I can clear out this particular cell so it becomes easier to understand. Okay, so it is giving you 6. Let me do that once again. Clear out this and then, okay, and let me change the format. So this is one way of doing it. Another way is you don't even have to specify the name of this parameter feed underscore dict. You just pass the dictionary and it will execute. Okay, but typically this makes the code readable. So that's the reason most of the places whenever you find TensorFlow code, you will see that they explicitly mention feed underscore dict so that the code is readable. Otherwise it can get confusing. So I will also comment this and retain the other format. Okay, so I hope it's clear. So what we are doing here, we are running the operation b, and what exactly is b? B is twice a into 2. So therefore what we are doing, and a has not been, doesn't have any value out here, right? So that's why we are feeding the value of a, and then the operation gets completed. So a gets a value of 3, and then it gets multiplied by 2 because that's what we said here. Therefore b gets a value of 6, and that's what is being fed into result, and that's what is getting printed here. Okay, now as I mentioned, a need not be just a scalar value. It can be a vector with a multi-dimension array and so on and so forth. So let's start showing you examples of that. Again, let me just clear out the outputs. Let me clear this, and let me also clear this for now. Okay, you can also do, before running this, we could also do clear all output clear. It will clear everything, but we'll have to start all over again. So I'm just doing individually. All right, so in this example we are taking a one dimension array where rank is equal to 1, and I'm feeding 3, 4, 5. Now let us see what happens if I run this, right? As you can imagine, it gets multiplied, each number gets multiplied, so the result is 6, 8, 10. Okay, now as I said, it can get more complicated. Now let's say this is a multi-dimensional vector. So if you, what happens if you feed this? Okay, so as you can see, this is pretty complicated now, but if you feed this again, all you're doing is there is a slight change here. Again, you can also create your dictionary outside and feed that here. You don't have to directly do it here, like in this case. You see, there are variations of the exact syntax in the way you write it, right? So there is a slight variation. So in this case, you are creating the dictionary straight away here, kind of in line, but here you created the dictionary separately because it's more complicated, and then you are passing that dictionary here. So I said dictionary is equal to A, and then I'm saying this is what should be the value of A. This is, and I'm feeding that, and then I'm using directly that dictionary here. Okay, so this is equivalent to putting this code here, right? So if we execute this, what happens? Same. So you get, because A was let's say this is a 3 by 4 by 2, right? So that is 3 by 4 by 2, right? So you see here, this is a multi-dimensional array. So you feed that, and the values you see here, it is 1, 2, 3, it became 2, 4, 6. 4, 5, 6 became 8, 10, 12. 7, 8, 9 became 14, 16, 18, and so on and so forth. Okay, I hope now you got an idea about placeholders. And in real life, what happens is you typically won't create these dictionaries manually. Since this is a quick demo, we did this. You will actually read the data into this dictionary, and then you feed that when you're doing the computation. Okay, so it could be a CSV file, or it could be an image file. So input is basically read and fed in. Usually it is also done in batches, so you don't read the entire thing because there can be a large amount of data. So that is the idea behind having these placeholders, and the way we feed these placeholders, there is a provision, deliberately there has been made a provision for this kind of getting data into the program in chunks. Okay, now in this particular example, we will close the session here, and then I will show you what is the other way of creating a session, right? So now if I close the session here, now if I try to do anything with the session, it will give us an error. So I will probably not do that right now. Now there is another way or another format, and this is a very common way of using the session, but I didn't want to start off with this because this could get a little confusing. A simpler way was to create session saying ses is equal to tf.session, but typically you will do it in what is known as a with block. This is a very common way of creating session. So once you have the graph, you would execute the graph in a session using a with block, and this is the syntax. So you say with tf.session as ses, all right, and then you put all your code here. So what will happen is you don't have to explicitly close the session. The moment this with block gets completed, the session gets closed. Okay, so let's just take a quick look at this example. Now, if we, let me clear this, current output, we clear. Okay, so this is the hello world example. A little bit earlier we did that. So I'm doing with tf.session as session result is equal to ses.run hello plus world, and then I say print result. Okay, so within this with block, I'm doing all my computation and this gets executed. Now let's say I try to run, remember I created a session here. Now if I want to, let's say, do something like run ses.run a, it is giving an error because the session is no longer valid, right? So you cannot, either you have to run this, if you want to run this, you have to run this in this with block, or you shouldn't have closed the session here, right? You remember this, we said session.close. So since we have closed the session, there is no active session, therefore it is giving an error. Okay, now there is a third way of creating a session, but for now I will skip it because that is very, very specific to notebooks and so on, so we will just avoid it. You start with, for beginners, I think the best way is to start with creating a separate session and then writing your code and then closing your session. Now of course, remember, if you don't do this part, ses.close, it will not give any error or anything like that. Only thing is that it's a good practice and your resources will get released Otherwise, if you do multiple of these programs, if they are running, then your resources will get blocked. That's the only thing. And to start with, it is simpler to do it this way. So initially when you're doing, you start with this, but as you move forward, as you become familiar with TensorFlow programming, I would recommend all of you to get into this model. Most of the programming, TensorFlow programming, is done like this with tf.session as says. Okay. All right. So that was one book or one page of code that we have done explaining about variables, constants, and placeholders. Now let me explain how the graph works. So in this example, we are going to see how the graph is created, how the graph gets executed, and so on. Okay. Now that we got a understanding of constants and variables and placeholders. Okay. So we will start as usual by importing our library, and as I said, whenever you create a TF or TensorFlow object, there will be what is known as a default graph, and you can get a handle of that by saying get default graph. So let's do that, and you can display the operations. Remember, every node in the graph is considered as an operation, right? So as of now, as you can see, we have not done anything. We have not created a constant or variable or nothing, right? So there is no operation. So by the way, let's do one thing. Let's start with all output clear so that I don't have to again do individually. So I'll just run these 2 lines of code. Okay. Now, so yeah, so we have the default graph, and as of now there are no operations. So there is a method called get_operations which will kind of display or show what are the various operations that have been performed on the graph. So as I said, to start with, there have no operations been performed. So when I try to display, it's empty. There are nothing is there, no operations. Okay. Now let's see what happens when we slowly, step by step, start writing or building the graph. So my first step may be to create a constant. Okay. Remember, in the previous example, I have shown you how to create a constant in the most simple or the simplest way, which is like constant and then the number, right? Now, a small extension of that is you can actually give a name to your constant. Now again, this need not be the same. I can say a is equal to name and xyz. I can give anything here. Okay, this is just for your reference, but here for simplicity, because there is a purpose why I'm using the same name as the name of the variable, and there are other reasons as well why you would give a name again to a constant or a variable. This is again useful when we are using what is known as tensor board. Otherwise it doesn't have much value. This additional name doesn't have much value. In this our case also, we will be seeing the graph, and that's why I'm using this, but otherwise this having additionally a name usually doesn't add much value. All right, so let's create a constant. I created a constant. Now let us see what's going on in the graph. So I will just say operations is equal to get operations, and if you see here, now you remember here it was blank. Now you see the first operation is showing up, and this a, that's the reason I put here. So it is showing as a, and it says that, okay, you have performed an operation and there is a constant. You have created a constant. Okay. All right. So let's move on. Let's say we want to create a second constant, and this is b. So if I see what are the operations, list of operations that have been performed, you see here there are 2 of them. So you have operation a, which is a constant, then you have an operation b, another constant. You recall, in the term operation here is not very intuitive, right? So we are just creating constants or numbers or variables, and it is saying it's an operation, but that's a terminology in TensorFlow. Everything is an operation here. Okay. All right. So then what else? Let's say I want to create a third operation, and that is basically adding, this is a real operation in normal sense as well. So let's say I'm creating C, which is adding A and B, and the C value obviously will be A plus B. Okay. Now, if we want to see what is in C, and we say C, you see here, it is not showing 30. It just says it is a tensor and it is of type int32, right? Because we have not executed the graph. We are still only building the graph. I hope this makes it easy to understand. Okay. So we are just building the graph. We have, till we do a session and run a particular operation, you're not actually executing anything. Okay, you're just building the graph. All right. So now let us see what are the operations. We have done A, B, and now C. So you will see there are 3 of them, A, B, and C. Okay. Now let's do one more operation, which is D. And here I am doing multiplication. Remember we did a tf.add. Now I'll do tf.multiply. And I'm multiplying A and B, and I'm calling this operation as D. So A has, I think, 10 and B has 20. So D will be actually 200 when we execute it. Right now it is just a tensor and it is of shape in 32. Okay, and once again we can see what are the operations: A, B, C, D. And let's do one last operation here, which is E, which is once again multiplication of C and D. Now that C has 30, which is A plus B, and D has 200, which is A into B. So now C into D will be 30 into 200, which is equal to 6000. But as we have seen earlier, that multiplication will not happen right now. So now you have built a fairly simple but operation graph, which consists of A, B, C, D, E, 1, 2, 3, 4, 5 operations. Okay, so you built a small, it's not a very complicated one, but a simple graph. Now you need to execute these operations. So what you need to do, you need to create a session. Okay, so ses.tf is equal to session, and then you can run these session, print ses.run e. Now, am I missing something? Do I have to initialize the variables? That's a question for you. Think and tell me. Do I have to initialize the variables there? Remember, I ran one piece of code. I think you must have got the answer. I don't have to, because I'm just using all constants here. I have not used any variable here, right? So I don't have to execute that piece of code to initialize the variables. So I can just create a session and run any of the operations that I want to run. So in this case, I'm running session E, operation E, right? This operation E. Now I can actually run individually. Instead of doing directly E, I could have run only A, or I could have run B, and so on and so forth. But in this case, I have run E, which in turn will do all the required computations, which is, for example, assigning the value to A and B and C, doing the multiplication and so on. All those operations will be performed, which are required to do the computation of E. Okay. Now, there is a small piece of code that you can use to find out what are the various operations that are there in this particular graph. In this case, of course, it was very easy, very straightforward. I have created A, B, C, D, E. But in normal programming, in real life, this can sometimes help to see what is there in your graph, what kind of operations are going on in your graph. So you can write this piece of code, and it may sometimes help debugging as well. Okay. All right. So I finished my session. What do we have to do? We need to close the session, right? Because I did not use the with block. So I need to close the session as a good practice. So I close the session. Good. So that's how the graph works. I hope it was helpful in understanding how variables and constants and placeholders are created in the previous example we saw, and how exactly you create a graph and then you actually execute that graph. That's the way TensorFlow program works. That's the structure of TensorFlow program. Okay, so now that we understood the structure of TensorFlow programming, let's take an example, and a classification example, and take some real data from outside, external data, CSV file, and try to solve a classification problem. For that, let's first go back to the slides and understand what is the problem statement, and then we will come back. Okay, so what is the case here? We have some census data, and which has all these features or variables, like the age of a person, what class, work class, what is his education, what is his marital status, gender, and so on and so forth. So there are a bunch of features that are available, and we have to basically classify, or not classify, we have to build a model for classifying whether the income of this person is above 50K or below 50K. Okay, so there is actually label data available. We will then try to build a model and then see what is the accuracy. So that this is a typical machine learning problem actually, but as I said, TensorFlow can be used for doing machine learning as well. So we will, as a simple example, we will take machine learning. So this is how the high level the code looks, and in TensorFlow programming we also take help of regular Python libraries, like for example it could be NumPy, or it could be scikit-learn, or it could be pandas in this case. And because before you actually develop or before you train your model, create your model, you need to prepare the data into a certain format. And sometimes if you're doing machine learning activity, you all are familiar, those familiar with machine learning will know, you need to split your data into training and test data sets. So all that can be done using regular non-TensorFlow libraries, right? So these are like regular Python libraries, pandas, scikit-learn, and so on. So we use that and then prepare the data and then use TensorFlow for performing either the machine learning or deep learning activity. Now, so what is the advantage of using TensorFlow? The main advantage is that TensorFlow offers high-level APIs, right? We talked about that. So in this case, we will be using, I'll explain what is in the slide, but before that I wanted to just show you what is the API that we will be using. So we will be using the estimator API. We will be using the estimator API to create a classifier, what is known as a linear classifier. Now, in order to do that, you need to prepare the data, and you need to prepare the data into a certain structure or format, and the API itself needs to be fed in a certain way. So that is exactly what we are doing before we get into the regular TensorFlow code. Okay, so these slides will quickly show you what exactly is happening, but I will take you into Jupyter Notebook and run that code and show you. So here we are importing the data. The data is, the name of the file is census_data.csv. It's a CSV file, and then there is income bracket is one of the columns, which basically is our target. That is what is used. That is the label rather. But this doesn't have numeric values, so it has the income. So we need to convert that into binary values, either 0 or 1. So that's what we are doing here. And then we are splitting using scikit-learn. We are doing splitting of the data into test and training, right? So this is a standard scikit-learn. People, some of you who are familiar with traditional machine learning, and you have done machine learning in Python using scikit-learn, will immediately recognize this. This is a sklearn is scikit-learn, and there is a readily available method to split the data into training and test. That's what we are doing here. And then you need to create what is known as feature columns and input functions before you can call the API, estimator API. That's what we are doing here. And there are different ways of creating the feature columns for numeric values and for categorical values, or rather for continuous values and categorical values. Okay, so that's what has been two types we are doing here. We will see again in the code as well. And then you create your model. So this is basically model is equal to tf.estimator linear classifier, and then you're feeding the feature columns, and also subsequently you will call the training by passing the input function, and you specify how many iterations to be done for the training process. And again, this is all typical machine learning process, so there is nothing specific for TensorFlow here. And then you evaluate your model, because this is classification model, so you can again take help of the scikit-learn to test the accuracy and get the reports, perform the evaluation and get the report like this one. Right, so this is the classification report, and you will see what is the precision, recall, F1 score, and so on. Again, this is a standard machine learning process. All right, so that's pretty much as far as the code here is concerned. Once again, let me take you into our lab, and we will get started with this particular code. Now, let me clear out the outputs so that you can step by step you can see the output. So this is our data, and we will actually, this is just a display here. The code starts from here. So before even we start with our TensorFlow part of it, as I mentioned, we now remember in the previous examples, the data was kind of cooked up. Internally, we created some data and we were using it, right? The constants, variables, and so on. Here is a real life example. So you are actually getting data from outside. So, before we get into TensorFlow, this is actually regular Python code. So we are using pandas, for example, to create our data frame. So we will import pandas, and then we will basically read our file into a pandas data frame, and this is how the data looks, right? And if you do ahead, it will give you about 6 readings or observations, 5 or 6 observations, and then you can take a look at how your data is looking. So for example, you have age, work class, education, and so on and so forth. Okay, and you see here this last column, income underscore bracket, it says whether the income is greater than 50k or less than 50k. So this cannot be understood, or this cannot be fed into our model, or so that's the reason we need to convert this. This will not be understood, right? So this needs to be converted, saying okay, maybe less than 50k is 0 and greater than 50k is 1. So that conversion needs to be done before we feed it into our model. So that's what we are going to do as we move forward. So this is the code for doing that. Okay, so we take this and then we define a function and then we run that function. So now we have, wherever it is less than 50k, it will have 0, and greater than 50k, it will have 1. So we have now updated the data. Then the next part is to split our data into training and test data set. So how are we going to do that? We again will take the standard Python library, which is scikit-learn, sklearn library, and we use an existing function there, which is train test split. And what we are doing here is basically splitting the data into, I'm sorry, I need to run this and then this. Okay, sorry about that. So once I run this, what are we doing here? Again, those who are familiar with scikit-learn will immediately recognize I'm splitting this into test and train. I'm saying test size is 30%, so 30% of the data should go into test, and training should have 70%. Okay, so that's all we are doing. 0.3 indicates 30%. So you can, again, this can be individual preferences. Some people do it like 50-50, some people 20-80, and in our case we are doing 70-30. So training is 70 and test is 30. Okay, all right. So we have, so far we've been doing regular non-TensorFlow stuff. So preparing the data so that we can now use for TensorFlow. And in TensorFlow, what we are doing is we will be using the API called estimator. Now estimator, in order to call estimator, you need to prepare what is known as feature columns. So feature columns have to be in a certain format. Basically, it is nothing but the columns. We have to put them in a certain format. And then when we are calling the training, we need to pass what is known as an input function. Again, a certain way in which you need to pass that function. So that is what we need to do before we create the model and run the model for training. So the next few lines will be doing that. Quick look at, before we even get in once again into the TensorFlow code. So this is just showing us what are the various columns, names of the columns of this data. Okay, so that is what is shown here, and this is more for when I was writing the code, I could copy paste from here. That's the reason this line of code is there instead of typing in these values. Okay, good. So now is where the actual TensorFlow action starts. So I import TensorFlow, and now I will use this feature column functionality to create my feature columns. And there is a certain construct how you create the feature columns. Again, probably the details of that is out of scope here, but just that you need to know that we need to create feature columns, and the way you create feature columns for continuous values and for categorical values is slightly different, and that's the reason you have two different blocks. Okay, so for categorical values you need to use what is known as tf.featureColumn.categorical column with vocabulary list. And again, within this, again, there are two ways in which you can create for categorical values. One is a vocabulary list where you know how many types are there. So for example, gender column can have only male and female. So in such a case, if there are, let's say, a finite number of values for a given column, then you use a column with vocabulary list. Okay, so and then you say what is the name of the column and what are the possible values. So in this case, male and female. Now there will be situations where the values that this column can have. Okay, first of all, it is a categorical column. That means it can have names or some non-numerical values, but the number of values is probably unknown or undefined. So for example, occupation. Now occupation can have any value. It can be self-employed, it can be a software professional, banker, a teacher, doctor. So many possibilities are there, and we don't know in the given data how many occupations have been listed, right? So that is where you use what is known as categorical column with hash bucket, and you specify the hash bucket size. So what this says is there can be a maximum of 1,000 such values. So typically if you give a safe number, safely large number, so that you don't run out of these number of occupations. So I think 1,000 is a safe number. I don't think there will be more than 1,000 occupations in a given data. So that's the idea behind it, but that's a judgment call we need to take. What should be the size of this bucket size, right? Hash bucket size. So these are two different types for categorical values for creating the feature column. So we will execute this for all the categorical columns. Obviously you need to know the type of the columns, and that is where, if you see right at the beginning, this information was provided. What is the data type, and you see here the column name and whether it is continuous or categorical. This information is provided in the census data wherever we pick this census data from. By the way, this was picked from online from a government website, and we stored locally. So on that website it is mentioned, the details of this data were mentioned, and they have mentioned whether each of these columns is categorical or continuous. So that information we have to use, and we have to create feature columns using this categorical method for the categorical type of columns. And then for numeric or continuous values, you just use what is known as feature column dot numeric column. Okay, so these are all continuous or numeric values like age, education number, capital gain, capital loss, hours per work. These are all numerical values or continuous values, right? So you just say tf.feature underscore column dot numeric underscore column, and then give the name of the column. So once you do that, I think I have executed the previous one. Yeah, this one. Now, so your feature columns are ready, and you need to basically create a vector of all these columns, and we call that as feat underscore calls, which is like a short form for feature columns. Now, as you have seen, I've mentioned earlier also, there are two things that are needed. One is the feature columns, and the another is the input function. So feature columns to first create the model, and then to train the model you need to create an input function. So now we have the feature columns ready. Next is to create an input function, and there is a certain way in which you need to, this construct is pretty much a very common construct, so we will use that. So the input function takes these x and y values for training and tests. You remember these are, the x train is the x values of the training data set, and y train is the labels of the training data set. So that's what we are using here, x train, y train, and then we specify what is the batch size. Batch size, you remember I mentioned, this is what will say how many records need to be read each time, right? So typically when we are doing the training process, we don't get the entire data in one shot. We do it in batches. So what size you specify here. Number of epochs, in this case we just say none, but number of epochs is again probably the definition is not required here, but at a very high level, how many times the entire data has to be passed through the model, right? So if you have 1,000 records and you pass all the 1,000 records 3 times for training purpose, then you call that as 3 epochs, right? So there is a difference between the batch size and epochs. So when, let's say we have 1,000 records and you're saying batch size is 100, that means there will be 10 batches, right? So if you take 10 batches, then that is 1 epoch gets completed. Okay, then the training obviously doesn't get completed in one round. Okay, so you need to pass this data again, maybe a second time or a third time till you get the right accuracy. That is known as epochs. Okay, again, if you need more details about this, you may have to go through the machine learning tutorial. I think it becomes much clearer. Okay, so you have your input function as well. Let's execute that. Okay, and now we are ready to use the API, right? So what will we do? We will create the linear classifier. using tf.estimator.linear classifier, and this guy needs feature columns, right? So that's why we did all that, so much of manipulations to create this feature columns. So we have feature columns, so we pass that and we create our model. There may be a few warnings, don't worry about that, so we will just ignore that. And now we use that model, and we actually, what we did is we created an instance of the model. We have not really run anything, we just created an instance of the model. Now we will create the node for training. So model.train, and this needs the input function. Remember, we created the input function, so we need to pass the input function, and then we say the steps is now telling how many iterations this training has to be run. So we are saying 5,000, and this it will probably take a little long, so we will, okay, but that's fine. I think we will leave it 5,000. Sometimes if you have probably a less powerful machine, you can cut it down to maybe 1,000 or something like that. But in this case, I have a fairly powerful system, so I think it shouldn't take much long. Let's go ahead and give a couple of minutes for it to get over. Okay, so let us go back. Yeah, I think this is done. You see here the hourglass has disappeared. That means this computation is done. Yes, okay, this is done, right? Saving checkpoint for 5,000. That means it is done. So training is done. So now what we have to do? We need to do the evaluation. So again, this is a standard machine learning method. So methodology rather. So training has been done with the training data set. Now you need to evaluate using your test data set. So that's what we are doing here. For example, you see here x_test is the test data set. Remember, we used scikit-learn to split the data into training and test data set. So x_test. And a quick question, why are we not using y_test here like we did in case of training? Obviously, we are expecting the model to predict the values, y values, right? So that's why we don't pass the y values here. All right. So let's execute this for doing the evaluation. All right. And then we put them in a proper format because the output doesn't come out in a proper format. So we put it in a list format, and then we can just check. Yeah. So this is done, and we can check what is the first element in this, what is the probabilities, and so on. So it's just a quick way to see if the values are there or not. You can take any value here, right? Any element here. All right. Now that the testing is done, what we need to do, again, we will probably put them in some kind of this is more of a formatting thing. We will just run through quickly, and then we will use once again scikit-learn for finding out the accuracy and so on, because scikit-learn offers what is known as a classification report functionality. So we will use that and find out how well our model has performed. So you see here again, people with machine learning background will be immediately able to recognize this. So it gives us what is the precision, what is the recall, and F1 score. This is pretty much like you're getting like almost 85% accuracy, which is pretty okay. And there are other ways to increase the accuracy. For example, you can run the training for more iterations. That is one way, get more data and so on and so forth, or use this is a linear classifier. We could have used a non-linear classifier and so on. So again, multiple ways of doing it to increase the accuracy. But the idea here was to quickly show you a piece of TensorFlow code. And that's what we have done here.
We had the original TensorFlow release of 1.0, and then they came out with the 2.0 version. And the 2.0 addressed so many things out there that the 1.0 really needed. So when we start talking about TensorFlow 1.0 versus 2.0, I guess you would need to know this for a legacy programming job if you're pulling apart somebody else's code. The first thing is that TensorFlow 2.0 supports eager execution by default. It allows you to build your models and run them instantly. And you can see here from TensorFlow 1 to TensorFlow 2, we have almost double the code to do the same thing. So if I want to do with tf.session or TensorFlow session as a session, the session run, you have your variables, your session run, you have your tables initializer, and then you do your model fit. X train, Y train, and then your validation data, your X value, Y value, and your epochs and your batch size. All that goes into the fit. And you can see here where that was all just compressed to make it run easier. You can just create a model and do a fit on it, and you only have like that last set of code on there, so it's automatic. That's what they mean by the eager. So if you see the first part and you're like, what the heck is all this session thing going on? That's TensorFlow 1.0. And then when you get into 2.0, it's just nice and clean. If you remember from the beginning, I said Keras on our list up there. And Keras is the high-level API in TensorFlow 2.0. Keras is the official high-level API of TensorFlow 2.0. It has incorporated Keras as tf.keras. Keras provides a number of model-building APIs such as sequential, functional, and subclassing, so you can choose the right level of abstraction for your project. And we'll hopefully touch base a little bit more on this, sequential being the most common form. That is, your layers are going from one side to the other. So everything's going in a sequential order. Functional is where you can split the layers. So you might have your input coming on one side, it splits into two completely different models, and then they come back together. And one of them might be doing classification, the other one might be doing just linear regression kind of stuff, or a basic reverse propagation neural network, and then those all come together into another layer, which is your neural network reverse propagation setup. Subclassing is the most complicated, as you're building your own models, and you can subclass your own models into Keras. So very powerful tools here. This is all the stuff that's been coming out currently in the TensorFlow Keras setup. A third big change we're going to look at is that in TensorFlow 1.0, in order to use TF layers as variables, you would have to write TF variable block. So you'd have to predefine that. In TensorFlow 2, you just add your layers in under the sequential, and it automatically defines them as long as they're flat layers. Of course, this changes a little bit as the more complicated tensor you have coming in, but all of it's very easy to do, and that's what 2.0 does a really good job of. And here we have a little bit more on the scope of this, and you can see how TensorFlow 1 asks you to do these different layers and values. If you look at the scope and the default name, you start looking at all the different code in there to create the variable scope. That's not even necessary in Tensor 2.0. So you'd have to do one before you do what you see the code in 2.0. In 2.0, you just create your model. It's a sequential model, and then you can add all your layers in. You don't have to pre-create the variable scope. So if you ever see the variable scope, you know that came from an older version. And then we have the last two, which is our API cleanup and the autograph. In the API cleanup, TensorFlow 1, you could build models using TF-GANs, TF-app, TF-contrib, TF-flags, etc. In TensorFlow 2, a lot of APIs have been removed. And this is they just cleaned them up because people weren't using them, and they've simplified them. And that's your TF-app, your TF-flags, and your TF-logging are all gone. So those are three legacy features that are not in 2.0. And then we have our TF function and autograph feature. In the old version, TensorFlow 1.0, the Python functions were limited and could not be compiled or exported, re-imported. So you were continually having to redo your code, and you couldn't very easily just put a pointer to it and say, hey, let's reuse this. In TensorFlow 2, you can write a Python function using the TF function to mark it for the JIT compilation, for the Python JIT, so that TensorFlow runs it as a single graph. Autograph feature of TF function helps to write graph code using natural Python syntax. Now we just threw in a new word in you, graph. Graph is not a picture of a person. You'll hear graph X and some other things. Graph is what are all those lines that are connecting different objects. So if you remember from before, where we had the different layers going through sequentially, each one of those white lined arrows would be a graph X. That's where that computation is taken care of, and that's what they're talking about. And so if you had your own special code or Python way that you're sending that information forward, you can now put your own function in there instead of using whatever function they're using. In neural networks, this would be your activation function, although it could be almost anything out there depending on what you're doing. Next, let's go for hierarchy and architecture, and then we'll cover three basic tools in TensorFlow before we roll up our sleeves and dive into the example. So let's just take a quick look at TensorFlow toolkits and their hierarchy. At the high level, we have our object-oriented API. So this is what you're working with. You have your TF Keras, you have your estimators, This sits on top of your TF layers, TF losses, TF metrics. So you have your reusable libraries for model building. This is really where TensorFlow shines, is between the Keras, running your estimators, and then being able to swap in different layers. Your losses, your metrics, all of that is so built into TensorFlow. It makes it really easy to use. And then you can get down to your low-level TF API. You have extensive control over this. You can put your own formulas in there, your own procedures or models in there. You could have it split. We talked about that earlier. So with the 2.0, you can now have it split one direction where you do a linear regression model, and then go to the other where it does a neural network. And maybe each neural network has a different activation set on it, and then it comes together into another layer, which is another neural network. So you can build these really